Hi grade 12s and welcome to this video. So this is going to be the function section of the May June 2025 paper 1 exam. Okay, so we have question 4 and question 4 says the graph of f of x is equal to, and they give us a hyperbola, okay, is drawn. Now M is the point where the asymptotes of f intersect. Remember what that point is, okay? The x value is whatever the x value of your vertical asymptote is, which is that p value. And the y value is whatever the y value of your horizontal asymptote is, which is that q value. Okay, so just keep that in mind in that. And then they tell us that C and D are the x and y intercepts respectively of f. Okay, so we've got C and D. Cool. Okay, and then they say A is a point on F that is closest to M. That is an important thing, and we'll speak about that if it comes up. If, they're probably going to ask us to find A at some point, but we'll speak about that. Okay, so the first question is to write down the coordinates of M. I told you that M is the intersection of these, right? The vertical and the horizontal asymptote. So what is the P value and what is the Q value? Remember that the general equation of a hyperbola looks like this: A over X minus P plus Q. So what is P and Q? P would be 3 because it's X minus B, X minus 3. And Q would be 4. So you can see now, if this is the intersection of P and Q, then it means the X value is 3 and the Y value is 4. So there we go. That's what M is going to be. M is simply just the point 3 and 4. Okay, so that is it for that question. Moving on to the next question. The next question, 4.2, says calculate the coordinates of D. Okay, so D, as you can see, is the y-intercept. It's intersecting the y-axis. So to find the y-intercept, you simply just make x equal to 0. Okay, so we'll just take the equation that we have. Let's just write that down. Okay, and then we are going to substitute in place of x 0. So that's 4 over 0 minus 3 plus 4. And then let's just find that answer. Okay, so 4 over negative 3, that becomes negative 3. And then plus 4. So what's 4 minus 4 over 3? If you just make the denominators the same, just to make this quick, it's going to be 12 minus 4, which is 8 over 3. So 8 over 3 is our answer over there. Okay, so we just found that intercept. So it just means that D is the point 0 and 8 over 3, because you know that the x value is 0. Okay, so that is that answer. Moving on to the next question. Don't forget to put it down because it's going to be helpful. 8 over 3. Okay, moving on to the next question. The next question, 4.3, says, if y equals x plus t is the equation of the line of symmetry of f, calculate the value of t. Okay, so it's just the equation of the line of symmetry. I mean, you could use that long way of what is the equation of the line of symmetry? The general equation will always be x minus p plus q. But I don't really see the use of doing that because they already told you the gradient, okay? It's just 1. You can see the gradient, the invisible one in front of the x. So if that is that, why don't we just substitute a point that is on this line if we have one? Okay, let's just see. Yeah, we will have one. So here is how this axis of symmetry works. And I hope I can just draw it well. It's going to relate to this. When we draw this axis of symmetry, remember, it's the line that perfectly divides this hyperbola into two perfect halves. So the left-hand sides will look exactly the same as the right-hand side. So we're going to have a line going through it, and it's going to pass this center. And here's the other thing, okay? It's actually also going to pass A. And we'll speak about what A is because they told us about A being the point closest to M, which is the intersection of your axis of symmetry. We'll speak about that. Okay, so since it passes this is the line y equals, x plus t. Since it passes 3 and 4, just substitute 3 and 4 into this equation. Okay, so 3 and 4 goes in. 3 is the x value, 4 is the y value, and then plus t. Then you're just going to take 3 over and becomes minus 3. So 4 minus 3 is equal to t, therefore t equals 1. Okay, so that's the value of t. Moving on to the next question. The next question says, determine the values of x for which f of x is less than or equal to 0. Okay, so let's look at that. Where does this graph have y values, that's what f of x stands for, that are less than or equal to 0? So since there are y values less than or equal to 0, you're going to look at it like this. You're going to look at your y-axis because that's where you'll find these y values. Okay, do you see that on this part of the y-axis? That's where you have values that are greater than or equal to 0. We want less than, so we want negative ones. So we're going to look at here. And here's something you can do. The minute you see, oh, you're looking at this part, you ask yourself, in relation to the x-axis, where is this? Is this above or below the x-axis? It is below the x-axis. So you're only going to take the parts of the graph that lie below the x-axis. And as we can see, that will be this part of the graph. That's all we're going to focus on. Okay, so let us find the x values for which this part of the graph exists. It starts at C, so we're going to have to find out what exactly C is. And then its values that are, if you line this up to the x-axis, do you see where these values are? Okay, these values. So whatever C is, its values that are greater than this, first of all. And then we have an asymptote. So it's not going to go beyond this. So you're going to have to see, we know that the asymptote is at 3, so that's helpful. So it's values that are going to be greater than whatever the C value is, but less than 3. So let's go ahead and find C and we'll be able to just solve for that. So C is that it's on the x-axis, it's the x-intercept. So you'll do that, you'll find that by making y equal to 0. Okay, we'll take our graph as it is and we'll just take our equation and make y equal to 0. And then we have 0 is equal to 4 over x minus 3 plus 4. Okay, let's see. So this is going to come over and it becomes a negative 4. And that is going to be negative 4 is equal to 4 over x minus 3. Then you can cross multiply and we're going to multiply, cross multiply. So that times that gives you negative 4x, okay, and then times the negative 3 is positive 12. Then 1 times 4 is just 4. And now you can take the x over to make it positive. So 4x now is equal to, you still have a 12 here, take your 4 over. Now we have 4x is equal to 8. And if you divide 8 divided by 4, therefore x is equal to 2. Okay, so there we go. We know what x is now. In other words, we know that C is that point 2 and 0. So in a nutshell, what's going on here is since this is 2, it means that the values of x for which f of x is less than or equal to 0 is where x is greater than or equal to 2, since they said less than or equal to 0. At 2, if you substitute 2, you get a y value of 0, so it's included here. So we have x is greater than or equal to 2, but less than 3. That's going to be our answer. And so we'll write that down. Therefore, x is greater than or equal to 2, but less than 3. Okay, I can also just write this in interval notation, which looks like this. We will say x is an element of, and then you're going to put the numbers that it ranges from. It's going from 2 to 3. That's it. So from 2 to 3, and then we're going to include certain types of brackets. Because this 2 is an included point, because it says less than or equal to, you're going to use a square bracket to indicate that 2 is included in these x values. And then for 3 is not included. It's just values less than 3, but not equal to 3. So you'll use a round bracket, and that's how we'll write that. Okay, moving on to the next question. now they finally ask us to calculate the coordinates of A. Let's speak about A. Remember how they said that A is that point that is closest to M. Here's what this means. See, the point A, it's spoken about more in grade 11, but it doesn't mean it won't appear in grade 12, because remember, grade 12 is really everything you've learned from grade 8. So think about it like this. You know how the hyperbola goes down like this, and then at some point it turns, and it does that, right? If you tilt your head this way, it kind of looks like a parabola, because it does a similar thing if you look at it in that way. It goes down and then it reaches a specific point where it takes a turn. That's why that point is closest to M, because it's the point at that point that's really where it turns. Now, from the previous questions, we already saw that this axis of symmetry that we found, right, that it also passes through A. So now we know that A is that point, it's that intersection of your hyperbola and the axis of symmetry. Now, there's a way to find this point. There are, in grade 11, or probably grade 12 textbooks as well, you will see summaries of this. Now, the reason you could just use the acronym is because if you had to do this yourself, you realize that it's the intersection between this line and this point. So you would literally have to equate this equation with the equation of the axis of symmetry. And looking at this, how many marks is this for? This is only for 3 marks. I mean, maybe that's actually what they want you to do. It could be that. Okay, so because of that, I'll show you 2 methods of working through this. So you could have done this, the study method, okay, where you actually studied that acronym that you're supposed to know for that. And that acronym works like this. You have to remember this word or this acronym. So A, P, A, Q. Okay. And it stands for a coordinate. And this is the separator between the X and the Y coordinate. So it's A plus P, A plus Q. But then what happens with the A is that it gets square rooted. Now, depending on where your X and your Y values are on this Cartesian plane, you're going to either have these being positive or negative. So here's how you see it. Because this is the X value, and you can see where this point is, the X value is positive, then the sign in front of the square root will be positive. So this is positive square root of A. And then for this one, because you can see that the Y value is also on the positive part of the Y axis, the sign in front of the square root will also be positive. So you could have done it this way, the study method, where you actually have to remember this APAC, and you would also have to remember the rest of the other ones as well, well, if you ever needed them. Okay, so if we use that method, this is what we would have. It will actually just be very easy to find. Okay, so this is what we have, and then we'll just put it down. So it's the positive square root of A. We know that A was 4, right? 4 over. So remember, it's that A over X minus P plus Q. So you can see A is 4, P is 3, Q is 4. Okay, so now we know what all of those are. So positive square root of 4 plus 3, and then positive square root of 4 plus 4. And then that would just give you your coordinates. That would be A. So it's going to be 2 plus 3, which is 5, and then 2 plus 4, which is 6. And that would be the point. 5 and 6. Done. Okay, so that's the study method where you know what those acronyms are and how to actually find those points depending on where they are on the X and Y axis. The other way you could have done this, because you see that it's a point of intersection between the hyperbola and the axis of symmetry, is you can equate them, these 2 lines, okay? The equation of this line was y equals x plus 1, okay, since t was positive, and then this one already has its equation. So we can just equate both of them as well. Okay, so f of x equals y, and then f of x was 4 over x minus 3 plus 4, and the equation of the axis of symmetry was just x plus 1. Okay, so yeah, we could just solve for x and y here. That's another way. So you see, you can still do it even if you didn't know that. You would just be able to see that, okay, those 2, they intersect. So this would be just simplifying 4 over x minus 3, and then we can just take that over. it becomes negative 4. So that's 1 minus 4, which gives you negative 3. So now you have x minus 3. Okay. And we can just simplify. So if you cross multiply, you see that you're getting an x minus 3 squared is equal to, because it's the same thing, and then 4 times the natural denominator of 1. Okay, so that's just going to be 4. So simplify that. Well, no, you don't have to do, you don't have to start squaring and stuff. What you can just do here is we're trying to solve for x. So this is squared. Get rid of the squared because I see that this is a perfect square number. So square root both sides. Square root that and square root that. But this is an equation, so you need to consider the positive and negative solution of this equation. Then we're going to have now x minus 3 is equal to positive or negative 2. Then finally take your negative 3 over. So x is equal to 3 plus minus 2. So here's the thing. In this one, you'd have either x is equal to 3 plus 2. Let's start with a minus 2. Or x is equal to 3 plus 2. So x is either equal to 1 or x is equal to 5. Okay, so you would decide whether x is equal to 1 or 5 looking at your graph. You see that there are 2 points of intersection. It's A and it's also this one over here. Because there was one that had 1, you can clearly see this is the one where the x value is 1. And then this is the one where the x value is 5. So you're just going to take the one where the x value is 5 and then use that. So you can use this. Don't take this one. Take this one. And then substitute 5 into either f or that. Since it's a point of intersection, it lies on both graphs. So put it in the easiest one. Y equals x plus 1. So just say y is equal to 5 plus 1. Therefore, y is equal to 6. See, still get the same answer. So A is 5 and 6. Okay, sorry that took long, but I just wanted to show you 2 methods to do that. Okay, so that is it for that question. Moving on to the next question. Okay, we're on 4.6, and 4.6 says, a single transformation is applied to f to obtain a new graph defined as h of x is equal to this. Okay, so we're going to have to see what changed. What was the transformation applied? Then they say a prime is the image of a under this transformation. Okay, calculate the length of a prime. Okay, so few things that we have to do here. First, we need to understand the transformation that happened here from f to h. What did they do to f to obtain h? And then after that, find out exactly what a prime is. We know what a is, okay? A lies on f. It is this point, 5 and 6. So based on the transformation applied, we would know how to change this point or how to really just make the transformation affect that point. Okay, so we know what the f graph looks like. It looks like that, right? 4 over x minus 3 plus 4. And it changed to this. So let's look at that and see what changed. Okay, so looking at these two, straight away, you see that nothing happened to the 4. Okay, nothing happened there. The only thing that changed is here. So this became negative, that became positive. So in this case, we can't really say, you see, it's impossible for you to say that, okay, maybe all of this was multiplied by -1, because that doesn't make sense even as a translation. What did you do that you just multiplied this to -1? Okay, was it reflected? Was it moved, shifted? That doesn't make any sense. So it can't be that case. What happened when you see that only one part changed, it didn't affect that. It means it never affected the entire y value of f. Okay, so since it didn't affect the entire y value, it probably affected the x value. And now we're seeing that something that was positive changed to negative. So what happened from here to here is probably that x had a negative applied to it, or we multiplied all the x values by -1. And what this means is that f was reflected across one of the axes. So here's what happened. If you took f of x and you said this is 4 over, and you have this x, and we make the x negative. Okay, because what happens when reflecting across this particular axis that we're going to speak about is if you reflect it, if that changes to negative, okay, then all the x values in that graph is also going to change to negative. They're going to get multiplied by -1. So what we have there is negative x, and then we still have the +3. It won't affect the 3. Okay, so it's the negative is being applied to the x only, not the 3, because the 3 is not an x value. Okay, then we have +4. So really, this is where we multiplied x by a -1, which really just means you reflected this graph through the y-axis. When reflecting through the y-axis, okay, you have two axes, and if you reflect through the y-axis, what it causes the x values to do is to change from whatever they were, they'll become negative. So if this point over here was -2 and 1, and it gets reflected across the y-axis, what it's going to become will be, this will change to +2, but the y value will still be 1. Okay, so that's what would happen there. Okay, so now it looks weird still and doesn't look like h yet. And this is the reason why. They factorized. So what they did was they left 4, and then they took out a common factor of -1 here. And when you take out a common factor of -1, what are you left with? You're left with +x and -3. And then you still have your +4. Then this negative, as you can see, this is negative. So they apply that -1 to the numerator, which is perfectly fine because it's just you have a numerator, you have a denominator. If there's a negative, you can either apply it here or apply it here. Okay, it's just the fraction. You can go to the numerator or denominator. So they moved it to the numerator, made that -1 multiply there, and that's why we ended up with this. Okay, so the big hint was this did not change, but this changed. Okay, and it changed where we start seeing things are becoming negative that were positive before. So this is a reflection in the y-axis causing all the x values to become negative. Okay, that's also another grade 11 info that you would, work on in grade 11 at first, and then you still work on it in grade 12, but you don't really learn it in grade 12. Okay, so we know the transformation that happens. This is a reflection, okay, in the y-axis. So now we can apply this transformation to that point A. Okay, let me just include that in order to obtain h of x, we set f of -x, okay, reflection in the y-axis. Now let's go ahead and apply that to A. A was 5 and 6, so A prime will be, if A was 5 and 6, then remember reflection in the y-axis causes all the x values to change. Okay, they will get multiplied by -1. So this gets multiplied by -1, making A prime -5 and +6. Okay, and then the main goal is for us to find the length of A prime. So just find the length. So this is the first point. The second point is 5 and 6. That's A. Let's go ahead and find the length of this line. So A prime, and you're going to just use the distance formula. So no, you don't need the distance formula. Look at how these look. If you're just going to plot them down on a Cartesian plane, just look at what they look like. If this is -5 and 6, -5 and 6 could be here, and then 5 and 6 is here. Do you see that these two have the same y value? So for you to get from -5 to 0, you move 5 units to the right. And then from 0 to +5, okay, that's a +5 value there. You move again 5 units. So how much units is that in total? It is 10 units. So A prime is 10 units. Done. Okay, so that is the answer to that question. And that wraps it up for question 4. Moving on to question 5. Okay, we're on question 5, and question 5 says the graph of f of x is equal to, we have A and plus p all squared plus. You know that this is not supposed to look like that. Okay, just remember the general form, okay, of a parabola in turning point form is A times x minus p all squared plus q. So they're just doing that thing that they do with the hyperbola, okay, where they give you a positive p instead of negative p. Okay, so just remember that they want you to find their p, not our original P. Okay. And then they tell us that this is drawn below. We have a point C, which is -1 and 4. It's the turning point of F. And B is just a point on F. They've given us more than enough information. Okay, turning point and a point is enough to find this equation. So show that f of x is equal to that. Okay, so this is enough. Just use it in turning point form. Now, you don't have to focus on what is P and what is Q. You're just going to have to rewrite it the way it should be written if you were applying these turning points. So here's what I mean by this. You know that the general equation of a parabola is A times, well, in turning point form, of course, minus P all squared plus Q. So if you were applying this, if you were substituting this into this equation, what would it look like? Okay, this is P, this is Q. So just put it in like that. So you would therefore have f of x is equal to A, and then we're going to say x minus, and that P value is negative. So that's -1 all squared plus Q, which of course is going to give you a +1. Do you see why they wrote it in this format? To show you that it's going to have a positive value there at the end of the day. So you focus on what it should be in this case, and then it will work out. Okay, so that's what it looks like so long. And I see that I forgot to add the Q. So Q is 4, so that's +4. Okay, so at this point, the only thing missing is the A. So you can just use 1 point to find A. So you're going to use B. So it's -4 as the Y value, and then A times and -3 as the X value, all squared plus 4. Okay, and then let's simplify. This is -4 is equal to, and we have A, and -3 plus 1 is -2. Squared is +4, and so this is +4A, and we have +4. But we can just take this +4 over. It becomes a -4. So this is 4A is equal to -8. And if you divide both hand sides by 4, -8 divided by 4 is -2. So there we go. We have A, and then we can just substitute, and then we're going to have to expand it to make sure it looks like that. So substitute it into the part that only needed A. Okay, so take that, and then since A is equal to -2, if we put that in and just expand it, we'll get our formula. So 2 now, okay, -2. And let's expand. So this is equal to, we still have -2 here. In here, this is squared. Square the first term, x squared. Square the last term, +1. First term times second term, x multiplied by 2. Okay, so it's +2x. And then we still have a +4 at the end. Then this is equal to, and you can now start distributing. So that's going to be -2x squared minus 4x minus 2 plus 4. Therefore, f of x is finally equal to -2x squared minus 4x, and that gives us a +2. And then just make sure that it is the same as what they told us it should be. Okay, there, -2x minus 4x plus 2, and that's what we have. Okay, moving on to the next question. The next question, 5.2, says, determine the values of k for which h of x is equal to f of x plus k will have no real roots. Okay, so this is just a nature of roots question. Also grade 11 knowledge. Okay, so let's write down our equation. We have h of x is equal to f of x, and we know this is f of x. So substitute that, and then of course plus k will have no real roots. Plus k. Okay. Now that we have this, here's what we can do. For you to have no real roots, we're going to look at what the discriminant should be. So, quick revision on this. If the discriminant is a value that is either greater or equal to 0, you will always have real roots. Okay, these roots may be equal or not equal, but they will be real. Okay, they'll be real values. But if your discriminant is something less than 0, then it's not going to be real. And that's because of where the discriminant is in the quadratic formula. And here is where that discriminant is in the quadratic formula. So you see this, the discriminant is this part, okay? We note that as delta. So if the discriminant is here, the reason why it's not going to be real is because you see that there's a square root there. So if you square root a negative number, okay, less than 0, you square root a negative number, you get a non-real number. That's why the discriminant needs to be less than 0 for you to have no real roots. So that's what we will focus on. That discriminant being less than 0. Okay, so let's go ahead and find that. So we're going to have to find out what is b, a, and c. So this is in the form of ax squared plus bx plus c. So you can see that the a value is -2, the b value is -4, and the c value is everything that does not have x in it, which is the 2 plus k. Okay, so that is going to be -4 all squared minus 4 times -2, and then a is 2 plus k, must be less than 0. And you simply just have to solve for this inequality. Okay, it's a simple inequality because it's linear, it's not quadratic. So this squared gives you 16, and then these multiplied give you +8, multiplied by 2 plus k must be less than 0. Okay, you can see that there are two terms here. So just take the 16 over. So you have 8, 2 plus k is less than -16. Then we can get rid of the 8. Remember, we're dividing by a positive number. It's not negative, so the sign will not change. Then you have 2 plus k is less than, and that will give you -2. Then you can take that +2 over, and this therefore means that k just has to be less than -4. And that is our answer. Okay, k just needs to be less than 4 for that to happen. You can even look at the graph to actually test out whether this is true or not. It will show you that. Okay, you can also write this as intervals. Okay, so that would be k is an element of, and you know that it's going from negative. Okay, so you're going to have to look at it on a number line for you to be able to see this. You can just do a quick number line, you can understand. See, you have -4, and it's saying that the k values are values that are less than -4. With interval notation, you're always writing the smaller number here and then the bigger number here. The smaller number, because it's heading this direction, okay, it's always on the left. The smaller number, it's heading there, so it's -infinity. So it's going from -infinity, and then the biggest number is -4. Of course, -infinity is not a fixed position, so it takes a round bracket. But this also takes a round bracket because, as you can see, -4 is not included in the solution. It must be less than -4, not equal to it. So those are two ways to represent that same answer. Okay, you can also just check in the graph. You see that your graph is here. If k, which was added to the equation, meaning it's going to either shift the graph up or down. If you shift it down anything more than 4 units, you end up with a graph that looks like this. And then if it goes anything below this, it will no longer have any roots because it will not intersect with the x-axis. Okay, so that is it. Moving on to the next question. 5.3 says the graph of y is equal to g prime of x. Okay, so the derivative of g, where g prime is the derivative of g, of course, is obtained when f is reflected over the line y equals 4. Okay, so that derivative, right? We get that by reflecting f over y equals 4. So we're probably going to have to find that. And then they say draw a sketch of g. So they give us information about g prime, but then they want us to draw g. Okay, if g of 0, which is where x is equal to 0, aka the y-intercept, where g of 0 is less than 0. So we have a negative y-intercept there. Then they say clearly indicate any stationary points on your graph. Okay, so let's just unpack what's going on here. So we are first told that we have y is equal to this, right? It is the derivative of g, but first of all, we find that derivative by reflecting y equals 4. But first of all, we find that derivative by reflecting y over the line y equals 4. So let's go ahead and find g prime first. So you find g prime by reflecting that f over the line y equals 4. Okay, so the graph of f, we know what that looks like already. We can just put that down because it's going to be helpful here. So if we take this and we put it down, and you're just... I don't think we should write it down as equations because it will be complicated to do that. Let's actually look at it as a graph first. Okay, so this is the graph of f. If you reflect it across the line y equals 4, here's where that line is going to be. It's where the y value is equal to 4. So it looks like this. It's just a horizontal line, really. Okay, so it's a line that goes like that, and then we just pull this up here. Okay, so that is y equals 4. So if this graph f is reflected across this line, all you have to think about is you're going to treat this line as if it is a mirror. Or really, like the mirror is here, so we need to see a reflection. So what happens is this line used to look like this. This graph used to look like that. And what's going to happen is if it gets reflected, it's just going to appear this side instead. I probably need more space. Let me move this down. Okay, so what happens is this graph is going to flip over. So I know I'm going to turn it around, but really what's going on is it is just going to get flipped over and it's going to appear here like this. Okay, so like that. Okay, so something like that. So that is a reflection across that line y equals 4. So this is g prime that they're referring to. Okay. Interesting things to note. This is a g prime, but do you see where it is? The x-axis is here, and then it's all the way up here. Do you see that it will not have any x-intercepts? That's a very important thing to note because this is a g prime, meaning there's a g. So if this is a parabola, right? G prime is the parabola, then it means the original function must have been a cubic graph, okay, cubic function for this derivative to be a parabola. Okay, so if you have y equals x cubed, if you derive a cubic function, you get a parabola. That's going to be coefficient times exponent. That's going to be 3x squared. You end up with a parabola. Okay, so that's what we need to note, and this doesn't have any x-intercepts. So the main question is draw a sketch, okay, of this graph G, but you need to also remember that the y-intercept is going to be negative. I don't think there's any calculations needed for this. Okay, and they also just say state any turning points. Okay, let's just see. First, I'm already going to point out there is no x-intercept here. That is a very important thing to note. If there are no x-intercepts in the derivative of your cubic function, right? Remember what the x-intercepts stand for. And I'll do a little sketch of that here. When you have a cubic function, let's say it's one where a is greater than 0. Okay, so it looks like an n, just more curved. When a is less than 0, it kind of looks like a backwards n, just more curved. So this one will look like this. That one will look like that, something like that. Okay, so let's say we have a cubic function. Now note that this cubic function has turning points, right? Clear turning points that we can see here, a maximum and a minimum. What happens here is if you derive this function, because a is greater than 0, it's a cubic function doing that. When you derive it, you end up with a parabola. But in your parabola, a will also be greater than 0. So you end up with a concave up parabola. But here's what's going to happen. This concave up parabola is going to have x-intercepts, okay? Because you can see that we have turning points. So the x value of it should be really shifted a bit. So the x values of your turning points will also be the same x values for your x-intercept of your parabola. So if this is f prime, that's how this works, okay? So here, your x-intercept will have the exact same x value as your turning points x value in your cubic function. But here's the problem with this one. this one, the parabola does not have any x-intercepts. So you see that. So the cubic function will not have turning points. That's what's going to happen. We won't have any turning points for the cubic function. And the reason I'm saying this is because they specifically say clearly indicate any stationary point. So we actually have to address that instead of going through a whole, thing of trying to actually find that graph and then you end up finding out that there actually aren't any stationary points. Then it'll be a waste of time. Okay, so it's not going to have any stationary points because it does not even have any x-intercepts. It does not intersect the x-axis. So yeah, sure, because this one is concave up, it's also going to be a positive cubic function. It's just not going to have any stationary points. So this is what it's going to look like. And now I'm starting to realize that's why they gave us this information. That's why they told us that the y-intercept is going to be less than 0. Okay, so here's the thing. It's going to look like this. So it's going to go like this. It's still going to kind of look like an N, but no curves like that. So it's going to do something like this and then like that. But the y-intercept is going to be negative. So this graph, we're going to need a negative y-intercept. So maybe move it down like that rather. Okay, so it's going to look like that. That's what this graph is going to look like. And it's actually going to have one point. Well, it has one specific x value only. You see, because this is your parabola's turning point, the x value of the parabola's turning point is also going to be the x value of your cubic function's point of inflection. So that's going to be there. But I don't think it really means anything here. But yeah, so that's what it's going to look like. It still looks like a positive cubic function, right? But it just doesn't have any curves because it's not going to have any stationary points. And then it will also pass the y-axis on the negative part of the y-axis. So what I see here is just from observation. I don't really see a need for calculations. I'm just trying to see where, because everything seems like it was already here. If we knew what this one looked like, then we immediately know what that would look like. Okay, so that is G. So you wouldn't really need to draw this, and your graph is just going to have that. So let me actually just clean this up. So we only put what they asked us for. Okay, so that's what it looks like. Just have the x and y axis, that's negative, and it just goes like that. Okay, so that is it for that question. And that concludes it for question 5. And then we move on to the last part of functions, which is question 6. Okay, we're on question 6, and question 6 says, the graphs of f of x, which is p to the power of x plus q, and g of x, which is mx plus c, are drawn. Okay, so we've got an exponential function and a straight line. Then they tell us that A, which is 3 and 4, is a point of intersection of f and g. Okay, so that's over there. Then B, 0 and negative 3, is the y-intercept of f, as we can see. And lastly, E is the x-intercept of G. Okay, so those are the things that we have. And the first question is to calculate the values of P and Q. Okay, P and Q lie on the exponential function. Let's see what we have. Okay, yeah, we have more than enough information. We've got 2 points. We have enough information. So since you're looking for P and Q, if you're looking for 2 variables, you need 2 pieces of information, or at least 2 equations, to find those 2 variables. So let's go ahead and write that down. We have y is equal to p to the power of x plus q. So we can substitute these 2 points. Let's go ahead and start off here. So if you're substituting negative 3 as a y-intercept, this is the point 0 and negative 3. Okay, so that's what we're going to put in here. 0 and negative 3. And this is going to be negative 3 is equal to p raised to the power of 0 plus q. Okay, so this is negative 3. Remember that anything to the power of 0 is 1. So yes, this is a p, but regardless of whatever number p is, it's going to be raised to 0. So it gives you 1 and then plus q. And then this is negative, well, that comes over and becomes negative. So q is equal to negative 3 minus 1, which is negative 4. Okay, so we have that. now we can update our graph. Okay, this should be f of x, not y. So f of x is equal to, and we just have p to the power of x minus 4. Okay, now we can use this, and we can use the second point that we have, which is 3 and 4, because it lies on the cubic function. So we're going to substitute that a value of 3 and 4 in place of x and y. So the y value is 4, the x value is 3, the minus 4. If you take that over, it becomes positive 4. So 4 plus 4 is 8, meaning p to the power of 3 equals 8. So you're going to have to make, in this case, the exponents the same. So how do we get the exponents to be the same? If you rewrite this as 2 to the power of 3, then you see now the exponents are the same. And since the exponents are the same, their bases are the same. So p is equal to 2. So there we go. We found p and q, which is what they asked us for. Moving on to the next question. The next question asks for the range of f. Okay, so with the range of f, it depends on, remember, it's all the y values of f. If you're looking at this graph of f, do you see that it only has y values that are starting from whatever this is, and then it's everything that is greater than that. There's no y value down here. Okay, so you need to find out what exactly the y value of that horizontal asymptote is. And that will always be your q value. We found q to be negative 4. So it means if this is y equals negative 4, then your range, all the y values of this graph would be starting from negative 4 and then moving up to positive infinity. So that is where y is greater than negative 4. Okay, so from negative 4 to positive infinity, and you see that it's not equal to because you have an asymptote at this point. And then in interval notation, remember it's still the y value, so we'll say that y is an element of, and we're going from negative 4 to positive infinity, greater than. So on the number line, it's going from negative 4 and its values greater than it. Okay, so positive infinity. And you're going to use brown brackets for both of them. For negative 4, it's because negative 4 is not included. Okay, it's not, the graph doesn't get equal to negative 4, but it's greater than negative 4. And then for infinity, infinity is not a fixed value, so takes the round bracket. Okay, so that's it. Moving on to the next question. Okay, the next question, 6.3 says, so the graph of the inverse of g also passes b. Determine the equation of g in the form of y is equal to, okay, it's weird. They're giving you information about the inverse, but then they want you to find g, the actual original. Okay, so it also passes b. Let's see what that means and how that can help us to find g. So yeah, now it makes sense because there's no way you could have just found g. He's missing. But they tell you that the inverse of g, the inverse of this graph, passes through b as well. That is a very important point. So this means when we draw the inverse, it also passes b. You can think about it like this. Remember, the inverse is where you swap x and y. So these x and y values would swap. Meaning, if it also passes b, b is on the y-axis here. Meaning it's the point 0 and negative 3. What will this point be on g, the original? Since this one is on the inverse, the original one is just going to swap the x and y values, making this negative 3 and 0. This is an x-intercept. Do you see that E is an x-intercept? So what that means is that E is actually the point negative 3 and 0. So interesting how they gave you information about the inverse so that you can use that information to find the original. So that, them telling us that it passes B, was really just telling us that if on the inverse it has a y-intercept of negative 3, then it means on the original it will have an x-intercept of negative 3. Okay, so with that information, we now have 2 points on G, and we can actually find the equation using, y equals mx plus c. So we've got E, negative 3 and 0, and A, 3 and 4. Let's go ahead and use that. Okay, so the gradient is equal to y2 minus y1 over x2 minus x1. And so we'll say top minus bottom. It's just easier like that. So 0 minus 4 over negative 3 minus 3, which gives us, it's going to be negative and negative, so they'll become positive. But this is 4 over 6. 4 over 6 is really just 2 over 3. Okay, so the gradient is 2 over 3. And then now we can find the equation of the line using 1 point. Use the easiest point. So I'm going to use this quick method where we say y minus y1 is equal to m times x minus x1. You can use the y equals mx plus c. It's also fine. So in place of the gradient, I'll put 2 over 3. And I'll take an easy point. Let's use e. So this is going to be our x1 and our y1 that we'll substitute. So we'll say y minus y1, which is 0, is equal to 2 over 3, and then x minus x1, and x1 is a negative 3, so that's minus negative 3, which gives you a positive 3. Okay, so now this is y minus 0, which stays y, is equal to, and if you distribute, you just have 2 over 3x, and if you multiply 2 over 3 times 3, what happens? The 3's cancel and you're just left with positive 2, and that's our answer. Okay, so that is, and they did say in the form of y equals, so that is the equation of g, the original, okay, in the form of y equals. Moving on to the next question. The next question and the last question for this section says, write down the equation of g negative 1 in the form of y equals. Okay, so write down the equation of the inverse of g in the form of y equals. This is the equation of g. How do you find the inverse? Simply swap x and y and then make y the subject. So we'll say y is equal to 2 over 3x plus 2, but now we'll swap the x and y values. So this now becomes x is equal to 2 over 3y plus 2. And now you just have to make y the subject. So we can take 2 over, and that's going to be x minus 2 is equal to 2 over 3y. And then you can see it as divide both sides by 2 over 3, or you could see this as multiply both sides by 3 over 2. That's what will cancel this, because the 3 and 3 will cancel, the 2 and 2 will cancel. So here, when they cancel, you're just left with the y is equal to, and then this. Okay, when we multiply here, you can just rewrite it as 3 times x minus 2 over 2, and then they'll distribute in. And when they do, they will become, that's 3x minus 6 over 2. Okay, so that's what's going on there. And finally, this is equal to y is equal to, because you have to write it separately. So 3x over 2 is really just 3 over 2x. And negative 6 over 2 is negative 3. And that's our answer. So that is the equation of the inverse of g in the form of y is equal to. Okay, and that wraps it up for the function section of this paper. And I will see you guys in financial maths.